Today we will do the final portion of chapter number 6, chemistry, the chemical reaction. So we'll start off with exothermic and endothermic reaction. Now exothermic reaction is a reaction in which heat is evolved, whereas endothermic reaction is a reaction in which heat is absorbed. Okay, so dissolution of quicklime is a very good example of exothermic reaction. To dry calcium oxide, you put water. What happens? Calcium hydroxide is formed, as well as lot of heat. So CaO, calcium oxide, and cold water you put, of course. And then what are the products? There is only one product, that is calcium hydroxide, and lot of heat is evolved. So this is a very good example of exothermic reaction. The other one is the reaction of an acid and a base. So let me tell you the general equation. Acid plus base will produce salt plus water. This is a very important general reaction you got to remember, which is needed in class 10 actually. So any acid, let's say hydrochloric acid, and a base, let's say sodium hydroxide. So hydrochloric acid and sodium hydroxide will produce salt, NaCl, and water, and it produces lot of heat. So heat will be evolved in this reaction. So therefore it is called an exothermic reaction. So if you put sodium hydroxide and HCl in a test tube, the reaction takes place. You will see the reaction taking place, and then you touch the test tube. So the test tube becomes hot. The test tube becomes hot. So this is a good example of exothermic reaction. The other one is endothermic reaction, as we all know. Endothermic reaction is a reaction in which heat is absorbed. So the reaction of nitrogen and oxygen, N2 plus O2 produces nitrogen monoxide or nitric oxide. So, and this takes place, this reaction takes place by absorbing heat. It takes place at almost around 3000 degrees Celsius. Then at 3000 degrees Celsius, nitrogen and oxygen directly combine to form a gas, a neutral gas called nitric oxide. Similarly, the decomposition of calcium carbonate, CaCO3. So when you heat calcium carbonate at the temperature of 1000 degrees Celsius, 1000 degrees Celsius, it produces, the products are calcium oxide and carbon dioxide. So this is the reaction of, this is the very good example of endothermic reaction in which heat is absorbed. Now we come to oxides. Oxides is formed when a substance reacts with oxygen. For example, magnesium burns in oxygen with a dazzling white light to produce magnesium oxide, MgO. Yeah? Magnesium plus oxygen. So magnesium burns in oxygen. Burning is combustion. Combustion means reacting with oxygen. So magnesium burns in the presence of oxygen, means it reacts with oxygen to produce magnesium oxide. So oxide will be formed. Similarly, carbon plus oxygen. Carbon burns the charcoal. The charcoal burns in oxygen to produce carbon dioxide or carbon monoxide. So if you have lot of excess of oxygen, then carbon dioxide is formed. If there is deficiency of oxygen when the carbon burns, then it forms carbon monoxide. So this is by the direct combination, and the other is by the thermal decomposition. Like we have already done the I had already given an example of calcium carbonate, CaCO3 at 1000 degrees Celsius. What forms? Calcium oxide and carbon dioxide will be formed. So in this case, calcium also forms an oxide, carbon also forms an oxide, carbon dioxide. So two oxides are formed, calcium oxide and carbon dioxide. Similarly, lead carbonate, PbCO3. When you heat it, it decomposes into PbO plus CO2. So two oxides will be formed, that is the metallic oxide, lead oxide, and the oxide of a non-metal, that is carbon dioxide. So by the thermal decomposition of lead nitrate, PbNO3 twice, by the decomposition of a nitrate. So lead nitrate here decomposes into lead oxide plus nitrogen dioxide plus oxygen will be formed. The oxygen gas will be formed. So these are the oxides, the formation of oxides by direct combination, by decomposition, like calcium carbonate, lead carbonate and lead nitrate. So by the thermal decomposition of sulfates, iron sulfate, let's for example iron sulfate, FeSO4. Now iron sulfate dissociates into iron oxide, Fe2O3, Fe2O3 iron oxide plus sulfur dioxide and sulfur trioxide, SO3. So three oxides will be formed here. So iron sulfate dissociates into iron oxide, sulfur dioxide and sulfur trioxide. Similarly, Pb3O4, trilead tetraoxide, Pb3O4. Trilead tetraoxide decomposes into PbO plus O2. Oxygen gas will be produced, CO2. So these are the ways in which we can get oxides, like by direct combination and by these are the decomposition reactions of a carbonate, nitrate and a sulfate. Now we come to the last portion, the classification of oxides. Now there are many types, there are two types of oxides basically. One is the oxide of a metal and oxide of a non-metal. So oxide of a metal and oxide of a non-metal. But if we classify oxides, we can classify it into various forms, that is acidic oxide, basic oxide, neutral oxide, and the last one is amphoteric oxide. We'll discuss it later, this amphoteric oxide. Now first we talk about the acidic oxides. Now if you want to understand what an acidic oxide is, acidic oxide are basically, if you want to understand, they are usually oxides of non-metals. Oxides of non-metals. Oxides of non-metals are acidic oxides. For example, carbon dioxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide, phosphorus pentoxide, and carbon dioxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide and phosphorus pentoxide. They are basically the oxides of non-metals. So oxides of non-metals are acidic in nature. Why? Because they dissolve in water. To form carbonic acid, H2CO3. It forms carbonic acid. Nitrogen dioxide, in the presence of oxygen and water, it produces nitric acid, HNO3. Sulfur dioxide plus water produces sulfurous acid, H2SO3. Sulfur trioxide plus water produces H2SO4 sulfuric acid, and phosphorus pentaoxide dissolves in water to form phosphoric acid H3PO4. Hence, we call these oxides of nonmetals as acidic oxides. And acidic oxides, they turn the red litmus, blue litmus red. And sulfur dioxide reacts with NaOH. Okay, sulfur dioxide reacts with NaOH to produce Na2SO3, salt and water. Na2SO3, sodium sulfite and water. So since acid and a base, as we talked earlier, as I told you earlier, acid and a base will form salt and water. So sulfur dioxide is acidic in nature, therefore it reacts with a base to form salt and water. So oxides of nonmetals are usually, we call them, they are acidic oxides. Why do you call them acidic oxides? Because they dissolve in water to produce acid. Next is we come to is basic oxide. Basic oxides are usually the oxides of metals. Oxides of metals are basic in nature, because if you dissolve calcium, like for example, calcium oxide, sodium oxide. If you dissolve it in water, we get a base, calcium hydroxide, CaOH twice. We get a base, calcium hydroxide. Similarly, Na2O, you dissolve it in water, you get sodium hydroxide. So, oxides of metals are bases. They are basic in nature, and they react with an acid to form salt and water. Like magnesium oxide, MgO, reacts with an acid HCl, let's say, hydrochloric acid, to form salt and water, MgCl2 plus water. Of course, this is not a balanced equation. So magnesium oxide plus hydrochloric acid produces magnesium chloride and oxygen. So acid is reacting with a substance to form salt and water. What substance? It has to be a base. Only then acid will produce salt and water. So hence we have proved that magnesium oxide or the oxide of metal in general are basic in nature. So they are basic oxides. Another last one example we will discuss over here, like sodium hydroxide, NaOH, or Na2O plus H2SO4, sulfuric acid. So Na2O, oxide of a metal, and sulfuric acid here will produce salt, Na2SO4 plus water. So sodium oxide reacts with sulfuric acid to form salt and water. So any substance which reacts with an acid to form salt and water is a base. So sodium oxide is basic in nature. Now we come to is neutral oxide. So neutral oxides are those which are neither oxides, which are neither acidic nor basic. For example, neutral oxides, I'll give you an example here. Carbon monoxide. It's a very poisonous gas, but it is not, it is neutral. It is produced by the exhaust pipes of the unburnt fuel of the cars, okay, of automobiles. So it produces carbon monoxide, which is a very, very highly poisonous gas. Cigarette smoke has a lot of carbon monoxide. It's poisonous in nature, carbon monoxide, but it is neutral. Okay. Next is sodium, sorry, not sodium, it is nitric oxide. Okay, or nitrogen monoxide as we call it. And the other one is nitrous oxide, dinitrogen monoxide, nitrous oxide. And the other one is dihydrogen monoxide, that is simply water. They are neutral in nature. These are oxides of nonmetals. Oxides of nonmetals are supposed to be acidic, but there are some exception to the rule that oxides of carbon, nitrogen and hydrogen, they are neutral. For example, carbon dioxide. But carbon dioxide is acidic in nature. It is an oxide of carbon. Carbon dioxide is acidic in nature because it dissolves in water to produce carbonic acid, but over here carbon monoxide is neutral to litmus. Therefore, it is neither acidic nor basic. Similarly, nitric oxide, nitrous oxide and water, dihydrogen monoxide. So these are neutral oxides. Now we come to the last portion of this chapter, that is amphoteric oxide. So I'll rub this off and talk about amphoteric oxide. Okay. Amphoteric oxide. Amphoteric oxides are those somewhat like metalloids. Metalloids are elements which have the property of both metal as well as non-metal. Similarly here, amphoteric oxides have the property of both, they are both acidic in nature as well as basic in nature. So oxides of metals which acts as a base as well as an acid is called amphoteric oxide. Just to remember, we will not talk about in detail, just remember, it's very, very important to remember the names. The formulae I'll tell you. Aluminium oxide is amphoteric in nature, Al2O3. Zinc oxide, not manganese, it is zinc oxide and lead oxide. These are amphoteric oxides. It reacts with acid to form salt and water. It reacts with base to form salt and water. It reacts with acid also to form salt and water, with base also to form salt and water. And lead oxide reacts with an acid as well as a base to form salt and water. So it is acidic as well as basic in nature. These type of acids are called amphoteric oxides, and these are aluminium oxide, zinc oxide and lead monoxide. So I want to give you an example of reaction of zinc oxide in both the cases, which reacts with a base and an acid to form salt and water. Let's talk about hydrochloric acid in this case, and over here we talk about, let's talk about sodium hydroxide. Okay, sodium NaOH. Now zinc oxide is acting as a base here because it reacts to form salt and water. ZnCl2 plus H2O, salt and water. Over here now, when zinc oxide reacts with a base, sodium hydroxide, it will produce a salt called sodium zincate, Na2ZnO2. Na2ZnO2 plus water. So let me explain here. Zinc oxide, in both the cases, in the first case it is reacting with an acid, and in the second case is reacting with a base to form salt and water. So over here zinc oxide is showing basic in nature because it's reacting with an acid to form salt and water, zinc chloride and water, and then zinc oxide is showing the property of an acid or acidic oxide, which is reacting with a base to form a salt called sodium zincate and water. So these are the different forms of oxide: acidic oxide, basic oxides, amphoteric oxide and neutral oxide. So with this we come to the end of the chapter, chemical reactions. I hope you understood it. If you have any doubts, you can contact me as well. Thank you so much.